Welcome back. We will look at classifiers. So, the basic idea is, suppose you have data of this kind, you have one type of data like this and other kind. This is some xi and some function of xi data points. Okay. Suppose you choose, see these are all data, there are two types of data. Choose features carefully or you choose it well, or both mean the same. Something interesting can be achieved. I have g of xi. It will start looking like this. So, this is a classifier of the type y equal to mx plus b, just a straight line, simple. Okay. So, this is data space. This is feature space. So, many a times we do a mapping from data space to feature space, and then event space. This is machine learning, transforming the problem from feature space to event space. Event space could be simple like open the door or release the money in your ATM machine that you do. Actually, what you do in ATM is you supply features. Sometimes your face is recognized, your iris, sometimes your fingerprint, then you have a PIN code which you press, then put the credit card, all that. All those are basically taking features about you and validate it, and then it will release the money. So, it is a binary this thing, release the money or it says error. Okay. So, we generally tend to work in feature space when we have very good labeled data. And if you select the feature carefully, data separation happens very well, very easy, which means data separation means a very simple classifier can separate this data into two classes. So, this is very important, selection of features for a data. This is what your radiologist does. What the radiologist does, he takes the scan data with lot of this thing, then he will look at it, he will use his expertise and then do the following. It will all be like this, but he would probably circle at one or two places and then give some labels L1, L2. This is what a radiologist or a domain specific person does. It is exactly similar to what you do when you go for your motorbike or your car repair. Motorbike, that expert will check this thing and say there is some problem with the carburetor. This basically they are labeling the problem. Once you have labeled the data about the problem, you have known remedies or therapy or a replacement, whatever, right? Yeah. This is typically how this. So, the question is, given data and features labeled, how do I find this classifier? and there can be different type of classifiers. Suppose you have data like this, data like this. So, you have two types of data, one is an inner spiral, the other is an outer spiral, they are connected. How do I separate this now? I want a simple classifier. There is no way I can find any line which separates it, impossible. So, this let us say coordinate x1, x2. So, this data is function of x1, x2. There is no way it can separate. So, you need a very complicated classifier. Now, the question is, what can I do to solve such problems? With simple classifier, that is the trick. All you can do is implement this, implement simple classifier, do not try implementing complicated classifier. So, it is always important to look at the problem and try to modify or even transform the problem, so that you can implement a simple classifier. You have done this, where you had some complicated differential equation, d squared x by dt squared plus a dx by dt, etc., etc. You did Laplace transform. So, you ended up converting the problem into s squared plus as plus b type of thing, where it is easy to factorize the polynomial. So, we have been doing such things periodically in various domains, and the same methodology is used here. You have a complicated data. What works is a simple classifier. It is easy to implement a simple classifier. So, you have a complicated problem, you need to modify, transform, whatever, so that a simple classifier will do the problem, solve the problem. Suppose we have a problem, suppose we have a n class problem, what to do? So, we have a n class problem. What we do is we break it into two classes, repeat that further. So, what one calls hierarchical methods. So, a n class problem can eventually be broken down to n one class baskets. Okay. So, for example, you want to look at classification of boys, girls, men and women, adult I mean, men and women. Here you will break it into ladies or females, gents, male. Then you will break it into adult boys and young boys, and adult women and young, like that. So, given a n class problem, you can still continue to do this and break it. So, very rarely we attempt direct separation into n class, particularly in machine learning. It is a very challenging problem, and many times it is much easier to do this, more stable solutions, etc., etc. Okay. So, the learning focus will be on two class, focus on two class problems. We will focus on this. Okay. So, the best thing is to look at data. Let us look at the data of the following kind. Basically, I have a group of students, we want to separate them into boys and girls, okay. Okay, so let's, this is the problem, and as I said, the problem starts with today's approach is get data about the problem, So, I have height, let us say height is a obvious feature. Why it is obvious feature? Because you can observe. There are other features, for example weight, or I can even look at body mass index, etc., etc. So, for a given problem you will have a dozen features, and it is a healthcare problem, you will not have dozen, you will have few hundred features, okay. So, what is it that we observe? Very important. When I say observe, very important activity. Why it is very important is we have stopped observing. We also have stopped conversing. We are so busy collecting data, okay. What is observations? Generally girls are shorter than boys. We use this to design a classifier. So, let us look at the data and see what to do. Data. So, you have data from 60 centimeters, 62, 64, 66, 68, 70, 72, 74, 76, 78, 80. This is in centimeters up to 82. So, this is a feature height. Now, I want data, how many boys, how many girls, how many boys, how many girls. Zero, 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 1, 2, 4, 6, 4, 4, 2, 1, 1, 1, 2, 2, 3, 3, 4, 3, 2, 1, 0, 0, 0. So, this is the data I have in girls, various heights and number of girls with this height and number of boys with this height. Okay. This also reinforces our observation that on average, generally speaking, boys are taller than girls. Okay. So, what I want to find girls from girls and boys. So, what is the best way to do this? The best way to do this is to visualize the data. Visualize the data. That is why almost all data science, machine learning emphasize a lot on visualizing the data. A picture is worth 1,000 words. Okay. So, let us visualize the data. Okay. How do I visualize the data? So, this is 58, 60, 62, 64, 66, 68, 70, 72, 74, 76, 78, 80, 82, 84. I have given some overlap. So, boys 66 is 1, this is boy 1, 68 is 2, 70 is 4, 72 is 6, 74 is 4, 76 is 4, 78 is 2, 80, 82 is 1 each. Okay. So, it looks like this. Similarly, girls for girls 60 is 1, 62 and 64 is 2 each, 66 and 68 is 3 each, 70 is 4 which is same as this, 72 is 3, 74 is 2, 76 is 1, all 0. Okay, something like this. So, I want, so this is number of boys or girls with, let us call this variable xi which is height. So, you are now plotting a variable versus cardinality of counts with that variable. This is something you would have done in 6th or 7th. This is called histogram. Now, what do I want? I want to find a separator, okay, a separator which will separate boys from girls with very good accuracy or very low error, whatever you want. Now, suppose I put the classifier 1 is I pick a threshold. The threshold is height, because feature is height. I suppose I pick a threshold of 65, meaning all people with height greater than 65 similarly all people of height less than 65, because 65 is a threshold, 65 is one threshold happen. What answer do I get? All people of height greater than 65 centimeters, this orange thing, so are boys. which means all less than 65 are girls. Now you notice something. If I put a threshold of 65, so this is the classifier, a straight line like this, everything to the greater than 65 is boys. Boys are, for this classifier, the accuracy for boys is 100%, but a large number of girls, above 65, the number of girls will be 3 plus 4 7, 7 plus 3 10, 10 plus 2 12, 1 13, 13 girls out of 13 girls out of 18, 13 out of 18 is error. The total error is error of the boys plus error of the girls, right. This is the error, not a very accurate thing. Okay. The other extreme, suppose I select a threshold of 79. So, this is classifier 2. Classifier 2. I select a threshold height of 79, okay, and declare greater than 79 as boys, less than 79 as girls. If I do that, something interesting happens. I have for this 100% accuracy for girls, but for boys substantial amount. For boys substantial amount error will be there, right. Four plus 4 8, 8 plus 4 12 plus 6 18, 20, 21. 21 out of 28 boys is error. So, which is best? Threshold height for this. Suppose I select here either 769 or even here 71. You can work it out, you will actually get minimum error for this problem. So, the best solution for you is to select threshold 69 or 71, which will give you errors, both some errors of boys, classification of boys, and classification of girls. Both have non-zero error, but the total error for the problem is minimum. And in computing you can actually try all values and check for minimum error point, which means given one feature with this data, the best classification is what you get here. Can you get 100% accuracy for both? Not with one feature, maybe you need to look at multiple features. For example, you had a problem of the same problem, you had height as one, weight as another, which means you have to measure the weight of each student. You may end up getting something like this because it is 2 dimensional. So, the line classifier will, so you will have boys, girls here, and there may be some error, it is possible. So, you may actually improve the accuracy to about 90% correct. Then you can put one more feature, height weight, you can even put body mass index BMI, and you will get a separating hyperplane in 3D, which may actually give you about 94% accuracy. So, as you increase the features, better accuracy, but be cautious. You have to exercise caution here, which we will look at in our next class, but definitely with increased number of features, you will get better accuracy. This is, you have to exercise caution on two things. The reason you have to exercise caution on two things is, one, that it is on a small data. In practice, you may have to solve data for about 1 lakh or 10 to the power 6 or 7. So, on very large data, what you did may not work as well as it worked here, quite likely it will work better. Okay. So, typically you take very large data, you will have all boys here and all girls here, a small error will be there. Okay. So, this working on small data is actually called training. Okay. Plus testing you do, I will come to that exact breakup of training and testing. Please remember, this is practice. This is just a feel for the problem, that a feature like height can be used, it cannot be used alone, you need second, third feature. The height being the first feature which is most obvious, whereas weight and BMI both have to be measured. This can be observed, height. So, the most obvious feature is not necessarily the best. So, this is where expertise comes in. That is why many good doctors observe something which is not even recorded, but then infer very well. So, what is obvious is not necessarily the best. So, you have multiple features which relate to the data or to the problem that you are solving. Okay. Of course, you can have different type of classifiers. When I say simple, simple can mean a straight line, it can also mean a curve. Okay. But do not go for very complicated classifiers, do not go for very complicated classifiers like this, okay, which may work very well initially, but not necessarily the best. Go for simple classifier always, okay, classifier simple. This is the idea of what about clustering? When do you deploy, when do you go for clustering? Suppose I have data which is not labeled, okay, I have data xi, some cardinality of xi, various data. Suppose I have data like this. There are no labels. So, I want to basically separate, I have no labels, what do I do? Okay. So, this is where the idea of clustering comes about. So, as I said, while classification is done, very trivial problems actually have a simple classifier. A more complicated problem which we face, we can have the following: you have a classifier type of 1, you have a classifier 2, you have a classifier 3, you put this data, same features, get the answers. Then you can give, for example, 30% weightage for this, 40% weightage for this, 30% weightage for this, and then take a collective opinion. We do this. This is fusion of classifier, fusion of classifiers, many type of classifiers. For example, in your healthcare, you have a very frequently we come across such situations where we have a rare health issue. We may take emergency allopathy medicine. Later we may consult Ayurveda for a long term relief, and finally even after that we may actually resort to naturotherapy or palliative care. Okay. So such things definitely they do it in abroad. For example, many students do not join Stanford or Harvard for undergraduate because it is very expensive. Even for what they do is they spend 2 years in a community college, it is almost like our government colleges, and then transfer a lot of their credits from 3rd year onwards to Harvard and Stanford. So they get a Harvard and Stanford degree, but almost at half the cost that. So this kind of fusion, this kind of mix and match is very common and it works very well actually. Okay, this fusion of classifier methods give you much better result for the same data than a simple classifier. Okay, so the next topic would be clustering. We will take it up in the subsequent session.